Hello everyone. Today we will be looking at the valid anagram problem in the LeetCode. It is an easy question in which we are given two strings s and t, and we have to return true if t is an anagram of s and false otherwise. So anagram is a word that is formed by rearranging the letters of another word. Let's take a look at the first example. We can form the variable t by rearranging the letters of s variable, and that is why we will return true. In the second example, we will be returning false since they are not anagrams of each other. The first thought that may cross your mind by solving the problem will be to sort both the strings and then compare them whether they are equal or not. The sorting which is used when we sort the function in Kotlin is dual pivot quicksort, whose time complexity is big O of n log n, where n is the length of the string, and the space complexity will be big O of log n due to the recursive call stack. We can quickly run through this approach by an example. So let us consider these two strings which are given to us as the input to the program. So first we will sort the first string, and this will give us ART, and then we will sort the second string which will give us ACR. And if we compare both the strings, those are not the same, so we will return false. Now let us think about another approach to this problem. If we again look at the meaning of anagram, it states that anagram is a word that is formed by rearranging the letters of another word. It means that both the words will contain the same number of letters and will be of the same length. We can keep track of the count of each letter in the word using a hash map, where the key will be the letter and the value will be the count of the letter. Hence, we can create two hash maps and then compare whether both are the same or not. Let us quickly go through the example. So for the given inputs to the program, we will first create the hash map for the first string, and then we will create the hash map for the second string. In the first string, all the letters occurs exactly 1, so we will insert them in the hash map accordingly. Similarly, we will create the second hash map by looping through the string and inserting inside the hash map. At the end, we will compare whether both the hash maps are same or not, and then we will be returning the value. Here, both the hash maps are not equal, so we will return false. We can further optimize it by using only one hash map. We can loop through both the provided strings at the same time and then modify the occurrence of the letter accordingly. For example, if the letter exists in S, then we can increase the count of that letter. And if the letter exists in T, then we can decrease the count of the letter. At the end, we can check whether all the values in the hash map are 0 or not, and then return accordingly. Let us go through the code. At the start of the code, we can compare the lengths of both the strings and return false if both are not of the same length. Then we will initialize our single hash map, which will take the letter, that is character, as key, and count of the letter, that is int, as value. We will then loop through the first string. It does not matter since both words are of the same length. Get or default is a function that returns the value corresponding to the given key, or default value if such a key is not present in the map. Here we will provide the default value as 0, since we are incrementing or decrementing the value afterwards. So when the letter of the first string is not present in the hash map, it will enter 1 as a value. Or when the letter of the second string is not present in the hash map, it will enter -1. In the end, we will return true if all the values in the hash map are 0. The time complexity of this approach is big O of n, where n is the length of the string, and the space complexity will be big O of 1, since the hash map will not exceed 26 size, that is the total number of alphabets. Let us go through the code by an example. So here we are given two strings s and t. S contains nagaram and t contains anagram. So according to the code, we will loop through it only once and we will insert accordingly. If the letter in S is contained in the hash map, then we will increment the value of it, and if the letter of T exists in the hash map, then we will decrement the value of it. So accordingly, if we loop through the entire program, it will look like this. At the end, since all the values in our hash map is 0, so we will be returning true. There is one more smart way of solving this problem using arrays instead of hash map. Since in the problem we are given S and T consist of lowercase English letters, we can define an array of size 26 and initialize it with zeros. Each position denotes the English letter, so 0 will keep track of the letter A, 1 will keep track of letter B, and so on. To convert the letter A to denote the position 0, we will subtract the input letter with ASCII value of A. For example, if we subtract C from A, we will get 99 minus 97, that is 2. And in the array, C will be at position 2. As we did using the hash map, here also we will loop through the input string and increase or decrease the count of the letter accordingly in the array. Let us take a look at the code and go through one example. At the start of the code, we can compare the lengths of both the strings and return false if both are not of the same length. We will increment the count for the letters present in S and decrement the count for the letters present in T. In the end, we can return true if all the values in the array are 0. The time complexity of this approach is the same as the hashmap approach, that is big O of n, and space complexity will be big O of 1, since the array is of fixed size, that is 26. That is it for today. If you learned something, please give a like and subscribe to the channel. Thank you and have a nice day.